Okay, in today's lesson in 10.7, we talked about how we need now to take our focus or shift our focus from the angles and the arcs and start looking at the segments. So the first theorem that we discussed today is called the segments of chords theorem, where we have two chords intersecting in a circle. When the two chords intersect in a circle, like we have here, then we actually form four little bitty segments. And what we talked about today as our theorem is that one of our little pieces, I'm going to call that little a, times the rest of that particular segment, b. If I multiply a times b, that will give me the same product as if I multiply the two segments of the other chord. Okay? So one piece of the chord times the rest of that chord equals the product of the two pieces of the other chord. And we looked at examples here that they gave us. We had to remember that the FOIL method may come into play. Down here we looked at these examples and we said that we've got 6x, so 6 times x along one chord would equal to 15 times 4 along the other chord. So if 6x is 60, the length of x would need to be 10 units long. In 1b, we did the same thing. This time we had to do our little FOIL. So we're going to have that x times the x plus 12 is equal to the x plus 6 times the x plus 2, FOIL. The x squares fall out. That's nice. So x is 3. Now, if it says find x, I'm in good shape. But it may say, then what is the length of chord WY? So you may have to go back and plug in. So be alert to that. Our second theorem today involved two secants going to the same circle from an exterior point. And what we want to do with these, remember that the entire secant segment, so the entire length from J to G times its exterior portion, is going to equal to the entire other secant segment times its exterior portion. And what I alerted you to, and I want to alert you to again, when you're finding the entire length of JG, remember you're adding two segments together. You're finding this entire total through here. So your entire length is going to be 8 plus x, not 8 times x. And I get that a lot from students. And then the exterior part is 8. And then that equals to this entire thing of 16 times the exterior part of 6. And as you see, they have it worked out over here for you. So we practiced 3a and 3b by saying RU is x plus 9. The exterior part is x. And that equals all of RV, which is 9, times its exterior part of 4. So as we solve this time our x squared didn't fall out. So we need to try to factor it. It factors nicely. So x is either negative 12, that'd give us a negative measure, or it's positive 3. Okay, and the same thing we did over here. 6 plus x, the whole thing, times the outside part equals the whole other secant segment times its exterior part. see, 19 times 7 was 133. And 133 minus that 36 was 97. So I believe x was 16 and a sixth when we simplified it. Our last rule was when we have a secant segment and a tangent segment extending to the same circle from the same exterior point like we do here, we still find the entire secant segment times its exterior part, but this time that's going to equal to the tangent squared. And as I start to work this out, I see I'm going to have a quadratic equation, and when I get my 0, I have a quadratic equation that doesn't factor. When that happens, I have to use my quadratic formula. Remember that a is always the coefficient on the x squared, b is always the coefficient on the x term, and c is always the constant. And you plug that into your quadratic formula, and we get approximately 5.2 or negative 12.2. We did the same thing on number 4. They didn't have it worked out for us, so we got to do that one by ourselves. So we're going to have the entire secant segment. Now this time, remember guys, that's going to be 2x plus 4 is the entire secant segment times the exterior part equals the tangent part squared. So I'm going to distribute my x. Before I would even try to factor that, I would divide through by 2. Do you have to? Well, not really, but it sure does make life a lot easier. When that doesn't factor, then I've got to plug into the quadratic formula negative b plus or minus square root b squared minus 4ac all over 2a. Negative 2 plus or minus 204 over 2. So I'm going to have negative 2 plus or minus, okay, 204, 4 goes into that 51 times. So I'm going to get 2 root 51 over 2. And then this 2 will go into both terms in my numerator. So I'm going to have negative 1 plus or minus the square root of 51. Now that negative 1 minus root 51 is going to give me a negative measure. So I'm going to have to reject that negative. So negative 1 plus root 51 is my exact answer. I can plop that in the calculator and get an estimation depending on what they asked me to do. And they did say round to the nearest tenth. So I would put that in my calculator and round it off. But I don't have my calculator here at home with me. Okay, we'll answer any other questions that you have tomorrow in class. And we'll have that last section of the chapter, not tomorrow in class, but Thursday in class.